All right, this is part 4 of going over the second exam. And so we left off on question 18 here. This question says, a gas is cooled by removing 242 joules of heat from it, and by the gas doing 106 joules of work. What is the total energy, internal energy of the system? Well, we're going to use the formula given to us here that the energy, is Q plus W. And now it just becomes a issue of signage, okay? Is it negative or positive for both these? Well, it's cooled. Heat is removed from the system. So remember, it's from the system's perspective always. So if it's from the system's perspective, that's removing it. So it's gonna be a negative. And now the gas did 160 joules of work on the surroundings. Well, are you adding work to the system? No, you're adding work to the surroundings. That means the system is losing work, right? So it would be negative. Another way of thinking about it is, remember I was saying in class that if you're squeezing a gas, you're adding work to it, right? That takes energy. This is the opposite of it. It's expanding, so it must be negative, okay? And so that is negative 348 joules. And then the question becomes, is this an expansion or a contraction? Okay, and we just said that it's expanding because the gas is pushing out on the surroundings. It's losing work. It's working on the surroundings, i.e. the system is losing work, negative. Okay, if 4 moles of O2 react with excess methane, how much energy is released by the reaction? Okay. All right. 4 moles react with excess methane. Well, this reaction is for how many moles? It's for 2 oxygen. Okay. We have excess methane, so we know the limiting reaction is oxygen. Okay, and this reaction is for 2 moles, right? We have 4. 4 is twice as big as 2. So essentially, this reaction occurred twice as much. So if 2 moles give this much energy, then 4 moles are going to give twice that amount, right? So it should be 890, negative 890 times 2, and that's negative 1,780. Okay. Next one, sulfuric acid, H2SO4, exists in solution as follows. Which statement is correct? Now look carefully at how this is written. H2SO4 with an arrow, a single-headed arrow, goes to hydrogen ions and sulfate. H2SO4 is a non-electrolyte because it does not dissociate. No, I mean, look, it's dissociating into ions right here. That's pretty clear. It's a precipitate. Remember, precipitate's a solid in solution. There's no solid here. It says aqueous, aqueous, aqueous. Aqueous means it's dissolved in water. It's a weak electrolyte because it only partially dissociates. No, that would mean it had a double-headed arrow, meaning it's going back and forth. It's in equilibrium between these two. That's the definition of a weak electrolyte. So this is a strong electrolyte because when you put sulfuric acid in water, this reaction occurs to essentially 100%. It's going to all ions, okay? What is the oxidation state of technetium, Tc, in francium technetate? You notice I give you a really weird one, so you can't look it up, okay? I give you weird elements. So, I try to make these so you guys can't look them up. You might have noticed that. I know I can actually tell when you, just so you know, I can tell when you guys are Googling around. And, yes, that's cheating. Can I enforce that in any way? No. But I can tell. So when I look at your exam, I can tell if you cheat, okay? Do I think less of you because you cheated? Yes. Am I going to do anything about it? No. I can't, right? This is just the nature of it. But know that I know, okay? I can tell because the software is smart enough to know what you're doing outside of your browser, okay? And only those of you who happen to be watching this video will even know that nugget. Anyway. Oxidation state rules. Oxygen is usually -2, except if it's in elemental form or in peroxide. Francium is an alkali metal, +1. And so we have 3 of the -2s. So that's going to be a total of -6, right? We have 3 there. And so this is overall a neutral molecule. And so that means this is going to have to be +5, right? A +1 and a +5 to neutralize that +6. Okay, let's stop this video